Okay. So first thing we need to write for number one is the formula. The formula for the volume of a pyramid is 1/3 base area times the height. What is the base area of this pyramid? 81. How do you get 81? Yeah, this is a 9 by 9 square. So I'm going to do 9 times 9 is 81. Boom, 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 boom. All right. The height is what we're trying to find. So we won't be able to substitute a number in for that. If we substitute the numbers we do have though, the volume is 270. The base area is 81. So if we plug in, we get 270 is equal to 1/3 times 81 times the height. All right, can anyone tell me what is 1/3 of 81? 27. 81 divided by 3 is 27. So the first thing I would do is simplify this. Do the operations you can do, just like when you're doing the Pythagorean theorem, right? The first thing you do is simplify, actually square the numbers. To get h by itself, then I have one more step. E. To solve this for h, we need to get rid of that 27. And how do we get rid of the 27? Okay. No problem. How do we get rid of the 27? Divide. And 27 goes into 270 10 times. So the height is 10 meters. Does that make sense? All right. For number two, does anybody have an idea of how we could start this problem? That's right. You need to set these equal to each other. Those are vertical angles. They're opposite each other, which means if one's 96, the other one has to be 96 as well. They have to be the same amount. So we can write 2x plus 6 equals 96. And then to solve that for x is 2 steps. Subtract 6. 2x equals 90. And divide by 2. X is 45. The key part to that is really writing the formula and recognizing that those angles have to equal each other. I think if you write the formula, you're going to get that x is 45. I would bet Xander's life on it.
Whoa.
What?
What?
Yeah. That's how confident I am, Xander. Don't worry at all. All right, questions over the old bell work? Anybody need more time to write? Then let's talk about some cones. You know how many emails I've gotten? Mr. Lake, when are we going to go over cones? Mr. Lake, I'm dying to hear about the volume of cones. That's today. Resolve all of your issues. The volume of a cone is actually one of the easiest solids. Probably the only one easier is a cylinder. The volume of a cone is just 1/3 pi times the radius squared times h. The key thing that you have to remember is that h is the actual height of the cone. It is its altitude. It's how tall the cone is. It is not the slant height, right? It's h, not L. Those are different values. Yeah. Okay, it looks like, does anybody need more time to write? Okay, let's do an example. So for example, let's find the volume of this cone. First, draw this picture into your notes. To draw a cone, remember it's pretty easy. Just draw like a triangle, but don't connect the bottoms. With a straight line at least. Instead, connect the bottoms with like a rounded circle. And then on the back side, do like dotted lines for it. And that's a cone. To do this problem then, the first thing we're going to write is the formula. Volume is 1/3 of pi r squared h. Which, by the way, should make sense. Like if we look at this shape, it's very similar to a pyramid, right? And if you look at that formula, it's very similar to a pyramid's formula. In fact, it is the same formula. Except for this shape, the base is a circle. So the base area, capital B, would be the area of a circle. And pi r squared sounds like area to me.
Oh my God.
If you need the circumference, just use pi d. All right. Next thing we're going to do is identify our parts. What is the radius of this circle? 12.4. What is the height of the cone? And notice that that's the actual height, right? That's how tall the cone is. That's not the slant height. That's what we want. That's the height. That's the radius. So now that I have my values, I'm going to plug these into the old calculator or into the formula. So the volume will be 1/3 of pi times 12.4 squared times 17.7. And then now we grab the calculator, type that in. Parentheses 1 divided by 3, close parentheses, times pi times 12.4 times 12.4 times 17.7. Right, because 12.4 squared is just 12.4 times 12.4. And you get 2,850. 0.003 millimeters cubed. Bum, 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 bum. Yay. No, yay. That's the last lecture. The rest of the problems are guided practice, tomorrow's a review day, and then Friday's the test. Oh, yeah. Oh, well, we have it. The last one was a quiz. Friday's the actual test. The test of testing this. Okay. Now, Yates, anybody need more time? A little bit? Okay. Good. You need a picture of this? Okay. Let's have you try some then. First question. Find the volume of the cone below. This question is a little bit harder than the one we just did. Because for this cone, 8 here is not the radius. The radius is not 8. 8 is the diameter. You need to tell me what the radius is if the diameter is 8. Okay? Because it's like one more step. It's not that difficult to step, but it's another step. All right, 3 minutes on the clock. What? Parentheses 1 divided by 3, close parentheses. Or if you just want to type in the whole answer and don't put in the 1/3, just to pretend it's not there. And then after you get the answer divided by 3, that would be fine too. You know what I mean? You know what I'm saying? Picking up what I'm putting down? Buying what I'm selling? It's in the bottom. It's that X to the Y button. You have to click that and press 2. How do I? Oh, this is what I need. Is this what I need?
And then divide by 3.
Yep. Feel like
You can check it.
In fact, well, let's see how much time I got left. Yeah, I can check. Yeah, oh, that's set up perfect. I think that's right. We'll check. Yeah, right. Yeah, I think that should be. I think you need. Yeah. Full length across. The radius would be- Yay.
We gotta do
That E.
it. You don't know how to do it.
Then the radius would be if that's the diameter, the full length across, I mean the radius would be that, which gets. Okay, let's go over this. And in fact, if it's okay with everybody, let's pick on a random person. Does anyone have any objections? No? Okay, let's do it. 2, 4. That's an empty seat. 5, 1. Eric, you have to be the luckiest person alive. I feel like you get the random. That's all right. Start us off. What's the first thing I need? I need the formula. Okay. Are we going to Christian X or Xander? Xander, your odds. Christian, your evens. They saved you today. Christian, all right. If the diameter is 8, then the radius would be, thank you. That's right. So our radius is 4. And then Jacob, what's the height of our cone? Yeah. And now we just plug it. So the volume will be 1/3 of pi times 4 squared times 9. Type into the calculator. So again, if the 1/3 messes you up, you don't like that, just type in pi times 4 to the second power times 9. And once you have your answer, divided by 3. You should get that the volume of that cone is 150.796. 150.8, that would be fine. If you added it to 151, that'd be fine too. If also, by the way, if you're getting answers that are a little bit off of this, like you're getting like 149 or 152 or 53 or whatever, it could be that you're just using 3.14 instead of the pi key. I use the pi key, right, to get me a slightly more accurate answer. If you're using 3.14 and you're not getting quite what I get, but you're getting close, that's fine. You'll still get full credit. If you're like 10 units off, if you're like at 160 or 140, that's an issue. That means you're typing something wrong. All right, questions on this one? Mr. Lake, did I forget? Did I stop recording and start recording? I might have to actually upload this to YouTube and crop it, because this will be a double lecture then. It's a repeat second half. Okay. So you all might be feeling pretty comfortable right now. Like, geometry's not so bad. Life is great. Everything is rosy, rainbows, unicorns, stars. Well, here's the heat. Here you go. This is what you live for. Problems like this. Find the volume of this cone. Let me start you off with a little hint, because this problem is harder. 6 is not the height. It's the slant height. It's L. This is the height, and they don't tell me what that is. Or do they? Because this right here, if you're seeing what I'm seeing, that's a very friendly shape, isn't it? That's a right triangle. And if I want to find the side length of a right triangle, there's a theorem that I can use, a famous theorem, the Pythagorean theorem. A squared plus B squared is C squared. So first thing, write the formula, 1/3 pi r squared h. R is 3, but h we don't know. To find h, we will have to do h squared plus 3 squared is 6 squared. We'll have to do the Pythagorean theorem. So I will give you 3 minutes. Solve this for h. It'll take you 3 steps. then plug in, then calculator. What did I just do? Okay. So, Wyatt, I think you're next up. Do you have an idea what I could do next? What do I do with this 3 squared and 6 squared? Yeah, actually find out what they are by timesing them by themselves. We get 9, we get 36. That makes sense? All right, and then Ella, how do I get h by itself? I need to get rid of the squared, and I need to get rid of the 9. How do I get rid of the 9? Yeah, just subtract. So h squared is 27. And now this is the most missed part of this. I want to get rid of the squared. What's the opposite of squaring something? Square root. That's the key. It's not divide by 2. It's not 2 times h, right? It's h to the second power. It's h squared. So the opposite is the square root. So if you do that, you should get the square root of 27 is 5.196. So h is about 5.196. All right, now that I have h, I'm going to plug these into the formula. So the formula will then be 1/3 of pi times 3 squared times 5.196. And to make sure my answer is as accurate as possible, I'm actually not going to rewrite anything in this calculator. I'm just going to multiply this by 3 squared by pi by 1/3. That way I get the full decimal, right? Rather than just 5.196. And you might say, Mr. Lake, does that really matter? Could I just use 5.2 instead?
Can you go back over the number?
Ah, yes, I will go back. But I wanted to make sure you see this. And yes, it does matter. If you round too early and too often, the final answer you get will be so far from the, oh, I didn't actually hit answer. Mr. Lake. I know. The actual answer you get will not be very useful. If you do use the full decimal, you should get 48.973. Okay, now go. And again, if like, let's say this is a cone that you're filling up with popcorn, right? If you round, you're going to end up with just a little bit too little or a little bit too much popcorn, right? You want to have the perfect amount of popcorn in this cone. So you get your full money's worth and you don't waste any. You know what I mean? That's important. This is important life-saving stuff. All right, questions on this? Does anybody need more time to write? Okay, I'm going to tell you the next problem we're going to do. It's going to be a level question, extra credit, bordering on an extra credit level question. But I thought it was important because people often ask me, Mr. Lake, when are we ever going to use this stuff in the real world? Man, what's the point of this class?
Nothing.
Let me show you how you use it in the real world. Let's say you go to Baskin Robbins and you order the world's largest ice cream cone, as you are wont to do, right? So they give you an ice cream cone filled up with 100 miles cubed of rocky road. The radius of the cone they give you is 3 miles long, all right? But you're now left wondering, well, how tall is the ice cream cone? Can I fit it into my car? So what you're going to be asked to do is find the height of the cone. That way know if it can get into your car or not. And by that I meant it gives you the height, you need the radius. I taught all of second hour is that was the radius. And not a single person said anything. I mean, the math is very similar. So it turns out to be not a big deal, but whatever. The height of the cone is 3 miles tall. You need to know the radius. That way you know if it can fit into your car or not. Real world stuff here. What would you do in this situation without geometry? What? I don't understand. You would, I'm sure you've seen this. People go Baskin Robbins, they buy their ice cream. As they're walking to their car, calculators out. You see them on their cell phone touching stuff. They're on their calculator doing the math to find the properties of the cone. Now you can be a part of that. The 100 miles is the volume. It's filled with 100 miles cubed of ice cream. This is the radius, or this is the height. We need the radius. So here's what you need to do. Plug in this. Mint chocolate chip is pretty good. For that, plug in this for that, and solve this for R. Plug in those two numbers into the appropriate spots and solve this for the radius. to be fair, I think most of the people in the second hour were too shocked about the size of the ice cream cone and didn't notice the change from radius to height. Which is fair. But if you go in asking for the world's largest ice cream, you gotta be prepared to get 100 miles cubic ice cream. First thing I do is- What is it? What's it? Change that to this. What is it? Type that in. Third times five. Just the right side.
Oh,
You don't have to do that in the first step, but if you do, I think it makes the problem easier to see what you do next. Okay. So if we plug in, you should get 100 equals a third times pi times the radius squared times 3. And as I told you, the first thing I would do, you don't have to do this, but this is what I would do. I would simplify. What is a third times pi times 3? It's 3.14. Which should make sense, right? A third of 3 is 1, right? So it's 1 times pi. Okay, if I want to solve this for r, it is 2 steps. I need to get rid of the pi and I need to get rid of the squared. What is the opposite of multiplying r squared by pi? Divide. So I'm going to divide by pi to both sides. If you do that, 100 divided by pi is 31.831. Okay, and again, this is the part where hopefully we're okay with this by now. But if not, this has always been a struggle for some people. How do I get rid of the squared? What's the opposite of squaring something? Square root. And the square root of 31.831 is about 5.642 miles. So now that you've done your calculations, you realize 5.5 mile radius cone is a little bit too big to fit into my car. I'm gonna have to call a taxi or something. Get at least another car and then like suspend it between the 2 cars. And that's how you get your ice cream home. And without geometry, you would just be sitting in the parking lot watching the ice cream melt. Yay? Real world stuff here. I challenge you, give me a single math thing you've learned that you can't find a real world problem for. I can make one up like that. Everything has a real life application in it. That's why it's the best class. If you ask any of your teachers, what's the best class we teach it to people as, they will say, Mr. Lake's geometry.
They will say their own class.
No,
Yes, they will.
they wouldn't.
They will.
You tell me who that is. I'll go have a talking with them. Schnacker? Okay, well, I won't have good start talking with Schnacker. He'd fight me over it. Mr. Garrett? Oh, Mr. Garrett. What does he teach? Is he teaches algebra 1, right? No, he would say geometry. The only reason why algebra 1 matters is to get you ready for geometry. He'd have to admit that, right? Because geometry is just applied algebra 1. Like most of the problems we do is just, writing geometry formulas and then solving them with algebra 1 skills. Okay, it is, oh, you got 7 minutes left. That was the end of the lecture. Was anyone not here yesterday and needs a paper copy of this? Okay. This is the homework that's due tomorrow. The grace period would be Monday. All right, anybody else? All right, so again, these are technically due tomorrow, but as long as you turn it in by Monday next week, you're okay. You'll get full credit. Now, tomorrow is going to be a review day. Friday, we'll start the test and then we'll finish it on Monday. Friday, I won't be here. You'll have a sub to start the test.
Oh my goodness.
But Monday I will be here. So if you had any questions about any of the problems on the test, you could skip those and work on the ones you do know, and then wait till Monday to get clarification. All right, otherwise you got the last 6 minutes here to work on whatever you need. If you need any help on any of the homework problems, just let me know and we can do a few. Which one? On the new one?
Yeah.
Okay, let's do it. All right. Geometry, third hour. Nope, that's the guided notes. Where do I want this one? Okay, number 4. Remember that 2 polygons are similar if they are the same shape, which means one could be larger, one could be smaller, but they should have the same ratio between all of their sides. So the easiest way to test this is to set up a fraction. Largest side compared to the largest side. And say, is that the same thing as medium side over medium side? And is that the same thing as smallest side over smallest side? So what you need to do is in a calculator, actually divide each of those fractions. Tell me what decimal they are. If all 3 agree, yes, they're similar. If even one dares to disagree with the others, not similar. So like 12 divided by 8 is 1.5. If these other 2 are also 1.5, then it's similar. If even one is not 1.5, then those are not similar triangles. Any other homework questions? Okay. 5, same worksheet. Okay. Is it possible to prove the triangles are congruent? So remember, there are 5 ways to show triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. For these triangles, it's marked they have one pair of angles in common, right? A and D. Is there any other angles or sides that have to be congruent between these 2 triangles? Yeah, angle C here, if this is 90, then this one has to be 92, right? So that's another pair of angles. And then they both share BC as a side, right? So that's a pair of sides they have in common. So it looks like we've got an angle, and then a side not in between. And is angle, angle, side a valid congruence? Yep. That's the 4th one. So you could say yes, by angle, angle, side. All right, you have a minute if you want to start packing it. Christian, as a reminder, I got you signed up for seminar today. Test that. I think it's the final chapter. I can pull it up right now. Have a good day, everybody. Actually, let me clean. Bye. Scott?
Tomorrow afternoon, not tomorrow. Today, I'm getting my 2nd dose of the vaccine.
Sure.
So.
There's a good
class
chance that you might not be here tomorrow
Yeah.
and on Friday. Okay.
No, Friday I'll probably be here.
Okay. Well, tomorrow you're not gonna miss. I mean, it's just a review. So. Oh no, wait. Tomorrow is supposed to be the test, but you are 1 day behind.
Yeah, I am.
All right, but yeah, you won't miss anything. It would be a review day.
Can I get this thing
This thing? Yes.
and work on it in here?
Today, let me see. If you're signed up for anybody.
I've been there for 2 days.
Uh-oh. No, you got to go to who you're signed up for. Well, okay, you can go to them and say, hey, I have whatever you need. Mr. Lake. Would it be fine if I go see Mr. Lake?
Yes.
And then if they say yes,
My Spanish teacher.
yeah, then it'll be okay.
Leave this here.
No, probably take it with you just in case she says, well, actually, there's another quiz or something that we need to do. What?
Just don't come back or come back if she says no.
If she says yes, you can come back. If she says no, then you gotta stay there. I do. Okay, this is not the real 7.6. That's a dingus. But I believe this is the real 7.5 and 6. And then I believe this is the 7.3 and 4. And then I do have a 7.1 and 2. Okay. No, you actually just take the same seat. That way we don't have to. clean it, and I'll just move whoever's there. And then Christian, the one I need from you. Oh, hold on. Admit those people. Stop recording.